Welcome back, everyone. In this lecture, we're going to discuss for loops. Now, many objects in Python are iterable, meaning that we can iterate over every element in the object, such as every element in a list or every character in a string. And we can use for loops to execute a block of code for every iteration. So I want to focus a little bit on this term iterable because you hear it a lot, especially in Python documentation, and it's kind of a strange term if you've never heard it before. So all this term means is that you can iterate over the object, and that means you can perform an action for every thing in that object. So for example, for every character in a string, you can iterate through that string and then do something for every character. Often maybe you want to print out every single letter in that string or every single character in that string. So that means the string is an iterable object. You can work through it. You can also iterate over every item in a list. That means the list is iterable. And then you can iterate over every key in a dictionary. So the dictionary itself can also be iterated over. So kind of a little funny term there, but just think of it as a way of going through something. So let's go over the example of the syntax of a for loop. So this is the syntax of a for loop right here. Notice that we have a list defined, and then we have a couple of keywords, and then we're performing some actions. So let's focus on each aspect of this syntax. We start off with this statement, and this is just an assignment. We're saying my iterable, we're choosing that as a variable name. This could be my list, my items, my dogs, whatever you want, is equal to, and in this case, we're choosing a list. We're going to see other examples of other iterables in just a second. So we make some sort of assignment. We have a variable name there. And then we're going to say for, so that keyword for, item name. So this is a variable name that you can choose that's going to be a bit of a placeholder for every single item in your iterable object. So in this case, the item name actually represents the numbers in that list. Then we say in, so another keyword there, and then the variable name that you chose, in this case, my iterable. So we're saying for every item or item name in this list of 1, 2, 3, then we have a colon, and then we have some white space, and then we perform or execute some block of code. In this case, we're saying print item name. But you didn't have to actually use the item name. You could have just printed hello 3 times. So we're going to show more examples of that. But that's the basic syntax for a for loop. So let's actually explore these concepts in a Jupyter notebook and try to build a deeper understanding. So we're going to perform for loops for a bunch of different objects in Python. And I think by the end of this lecture, you're going to have a fair understanding of the basic idea of for loop and how to work with them. And this is really where you begin to level up your skills. So before, we've basically just been learning about data types, objects. We haven't really been able to construct anything yet. Once you start learning about control flow and for loops, and later on while loops, and then after that functions, etc., this is where we really start to be able to construct logical programs. Okay, so it's an exciting leap. Let's head to the Jupyter Notebook and get started. All right, let's begin with a simple example. I'm going to create a list called my list, and we're going to set this equal through the numbers 1 through 10. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then finally 10. And as a very quick note, you should not use list as a variable name here. Notice that it's being highlighted through syntax highlighting. That means list is a built-in keyword, so avoid using just list by itself as a variable name. If for some reason you accidentally already did that, go ahead and delete this, and then just hit kernel, restart, and then restart this, and that will reset all your variable names. What you will need to do is then rerun some cells if you already have stuff defined. So I just need to rerun that. Notice how now it's back at 1, so I've restarted everything. Okay, so I have this list 1 through 10. Now I'm going to create a for loop to iterate for every item in this list. So I start with the keyword for, and then I get to choose a variable name that's going to represent the elements inside of this list. So we're going to say for num in my list, that iterable, colon, I hit enter, and notice now how I have an indented block of code there. So now I can interact with those actual elements. So let's print them out. I'm going to say for num in my list, print num. And then when I run this, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually printing out this number for every number in that list. Something I want to make really clear though is that this particular variable name that you chose to represent the elements inside that list, it can be whatever you want. So here I chose num because these are numbers, but I'm going to just make it really obvious by choosing jelly and then saying for jelly in my list, print jelly. Run that again and you get back the exact same results. So again, this variable name can be whatever you want. This iterable can't be, it has to be predefined, but this variable name that's going to represent the actual objects inside that iterable, that is whatever you want. Now I also want to show you the point that we technically don't even need to use this variable name. We can still execute some block of code for every single item in this list, even if the code itself is unrelated to the item. So I can print hello for every item in that list, and we get back hello 1 through 10 times. And again, we can call this whatever we want. Num, run that, and we get back hello 10 times. So keep in mind, when choosing these variable names, you have full flexibility, so you'll want to choose a variable name that is somehow related to the object inside that iterable. Now let's combine our knowledge of for loops with a little bit of what we just discussed in control flow. Let's see if we can print out only the even numbers in this list. So to do that, what we're going to do is start off by saying for num in my list, and then I'm going to add in some control flow to somehow check if the number is even. So I'll say check for even here. This is just a comment. And then what I will do is the following. I'll say if num mod 2 is equal to 0, colon, print the number. So what I'm doing here is I'm saying, okay, for every number in that list, if the num mod 2, so remember that's the remainder when you divide by 2, is equal to 0. So if there's an even number and you divide it by 2 and the remainder is 0, then you can go ahead and print that number. So then when we run this, here we have all the even numbers, 2, 4, 6, 8, 10. And I can add even more control flow by attaching an else statement to this if statement, and then say print odd number. And we can even do some f-string literal formatting, so I can say if odd number, right there, run that, and it says odd number 1, 2, odd number 3, 4, odd number 5, 6. So this is some good work here as far as combining for loops with the control flow from before. Key things to note here is the indentation. So luckily Python is very clean because of the use case of indentation. So everything at this indentation level is inside of this for loop. So this entire block of code is going to execute for every single number in that list. And then we can see that this print num is only going to execute when this if statement is true. And this else indentation is lined up with this if. So we say if, this case, print num, else, and then we print out the odd number. And again, using some f-string literal here to nicely print out that number itself. All right, let's move along. So another common idea for a for loop is to keep some sort of running tally during multiple loops. And later on, we're going to show you the enumerate function, which kind of does this for you automatically. But for right now, what I'm going to do is say list sum is equal to 0. So let's try to get the sum of every number in that list. So I will say for num in my list, I will say the list sum is equal to the current list sum plus the number. And then I'm going to, outside of this for loop, print out the list sum. So when I run this, I get back 55. So this is a good example of indentation and a use case. So right now I have this list sum. So I'm saying my initial sum is 0. Then for every single number in that list, I take my old value for my sum and I add on the current number, and then I reassign that value to list sum. So I do that over and over again for every number in that list. And then at the end of this for loop, once it's done completing, so notice the indentation level here, I print out list sum. Let's see what would happen if I were to press tab here and have this print statement inside of this for loop. Now when I run this, I get back kind of the running tally of this sum. So it starts off at 0, and then once it has this first run inside of the for loop, it gets printed out. So then it has 0 plus 1, well that's equal to 1, so it prints out 1. Then we have 1 plus 2, well that's 3, then it prints out 3. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. So now we get the running tally, and it's only until the very end that we see 55. If we only want to see the last result, then I just have this print outside of that for loop. So that's why indentation in white space is so important. So we just saw how to use for loops with lists, but what about strings? Remember, strings are a sequence, so that means we can iterate through them, and we'll be accessing each character in that string. So we'll say for letter in, and let's create a string. We'll say my string is equal to hello world. Then for letter in my string colon, print out that letter. And I run this here, I can see HELLO space WORLD. So that's the way we can actually iterate through a string itself. And technically, you don't need to actually assign a variable name to the string. What you could do is just straight up put the string here. So we could say for letter in hello world, print letter. And we get back the exact same result. And I really want to drive this point home. You can call this whatever you want. So this letter variable name, you can say GHGH, and as long as it's the same thing inside of this, and you run this, you'll get back the same result. And the other thing I want to stress is that you technically don't even need to use this variable. So a lot of times what people do as they get more advanced in Python, for some reason they want to iterate something a certain amount of times. So imagine I wanted to print cool for as many times as there are characters here. So I see cool, 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 cool. What they do is instead of assigning this variable name, they just use an underscore. And that's really common syntax for when you don't intend to actually use that variable name as you iterate through. So they just use a simple underscore there. That way it's a little more readable. Okay, so that's iterating through a for loop. You can also use the same iteration for a tuple. So I can say tup is equal to 1, 2, 3. Then for item and tup, print out the item, run that, and I get back 1, 2, 3. Now, I want to mention tuple unpacking. So tuples have a little bit of a special quality when it comes to for loops. So if you're iterating through a sequence that contains itself tuples, the item can be used with tuple unpacking. So let me show you what I mean by this. I'm going to create a new list called myList, and I'm going to set this equal to a list of tuples. So here I have square brackets, and I'm going to make some tuple pairs. We'll say 1, 2, comma, then 3, 4, comma, 5, 6, comma, 7, 8. So notice what I have here. I have a list, and then there's tuple pairs as items in that list. So if I check out the length of my list, I have 4 items in it, where every single item is a tuple pair. So let's print out those items themselves. So for item in my list, print out the item. And when I run this, I actually see the tuples themselves. 1, 2, 3, 4, 5, 6, 7, 8. This sort of data structure is extremely common in Python. And later on, we're going to see that a lot of built-in Python functions actually take advantage of this built-in structure and return back tuples inside of a list. And the reason for that is something called tuple unpacking. Right now, we had to print out every single item inside this tuple. But what I could do is the following. I could say, let me delete this print statement. I could do the following. I could say for, and make kind of a temporary variable name that looks like a tuple here. So for AB in my list, then I can print the variable A, and then print the variable B. So note what happens now. I'm saying 1, 2, 3, 4, 5, 6, 7, 8. So what's actually going on here? Well, this is called tuple unpacking, where you kind of duplicate the structure of the items, in this case, tuples, inside of this sequence, and then unpack them. So now I have access to the individual items. So if I only want to print out the first item in those tuples, so I run this, I get back 1, 3, 5, 7, because now I'm only printing A. So this is known as tuple unpacking, and technically you actually don't need these parentheses here, so it's a lot more common to see it done this way, with no parentheses. So now I say for AB in my list, print A. Let's see what happens if we print B. We should get back all those even numbers, so that second half, that 2, 4, 6, 8. So again, this is tuple unpacking, and you're going to be using it a lot as you start working with more built-in Python functions, because a lot of things will return kind of pairs and sequences in this manner, where we have a list of tuples. And I want to show you one more example. Let's say my list is equal to a list 1, 2, 3, 1, 2, 3. Well, let's make it some different numbers. Say 5, 6, 7, and we'll do one more with 8, 9, and 10. I skipped the number 4 here, but no big deal. We'll say for item in my list, print item, and there are my 3 tuples, but I can do tuple unpacking here. So the way I can do that is make up 3 variable names, separate them by commas. So I can say A, B, C, Notice I don't have to use parentheses, and then I can print out whichever one of these I want. For example, if I just want to print out 2, 6, and 9, those middle numbers, I would just say B, and there we go, we have access to B, so just the middle numbers. So this is really useful when you maybe wanted to reorganize these structures into some other manner, or maybe you only want to deal with the first item in these tuple pairs. Okay, so that's tuple unpacking, and now let's finish off this discussion about for loops by discussing how to iterate through a dictionary. So to do that, we're going to create a dictionary called D. It's going to have K1 as a key value, and we'll have the number 1 as that value. We'll say K2 here, :2, and then we'll say K3, :3, and then I'm going to, for item in D, print the item. So this is something that's kind of interesting. Notice that by default, when you iterate through a dictionary, you only iterate through the keys. So K1, K2, and K3. If you actually want to iterate through the items themselves, what you need to do is call .items here. And now when you run that, you get back these tuple pairs, K1 with 1, K2 with 2, K3 with 3, which means we can use the same tuple unpacking technique we just discussed. So instead of item, what I can do is say key, comma value, and let's say I only wanted to print out the values. Then I could say for key value in D.items, print out the value, and now I have 1, 2, and 3. Again, taking advantage of tuple unpacking here, because D.items returns back something in this sort of format. And more likely it's this sort of format. We have a key and a value. So we're using the same tuple unpacking that we just discussed, now with D.items. So by default, when you iterate through a dictionary, it's going to be the keys. If you want to iterate through the items, you can use tuple unpacking to grab both keys and values. If you only want the values themselves, what you could do is say D dot, and then call values off of this, run that, and it'll only print out the values 1, 2, 3. The last thing I want to note here is that dictionaries are technically unordered. This is a very small dictionary, so it looks like everything's going in order, 1, 2, 3, K1, K2, K3. But if you have a very large dictionary, there's no guarantee that things are going to be sorted or in any sort of order. So keep that in mind. When you iterate through a dictionary, there's no guarantee that you're going to get things back in the order you put them in. Okay, so now we've learned about how to use for loops with tuples, lists, strings, and dictionaries. This is going to be a really important tool for us, so make sure you understood it well with the above examples. Specifically, make sure you really understand the white space. So probably the most important thing to get out of this lecture is the fact to use this for keyword, any temporary variable you want, you say then the keyword in, some sort of iterable object, either values, the list, or a string itself, as we saw up here, colon, and then in this indented block of code, that's going to execute every single time for every single iterable in that list. Thanks everyone, and if you have any questions, feel free to post them to the Q&A forums. I'll see you at the next lecture.